Hi there, welcome back to thinktankonline learning. So in this video, I want to find the first order partial derivative of this function. So first of all, we're going to find partial f, partial x, then partial f, partial y, and final partial f, partial z. So as for partial f, partial x, we're just going to treat this function. Let's say we're given x to the power a, okay, and the derivative is going to be a x. We're going to just drop the power, then we're going the power minus 1. Okay, so I'm just going to do the same here. So what we're going to do, what is our power? Power is y to the power z, okay, x to the power y to the power z minus 1. Okay, so let me put brackets here. Okay, so this is easy. And now I want to go to partial f, partial y. Okay, so what I'm going to do is that I have, unfortunately, y is raised to the power x. So what I'm going to do, I want it to be linear, so I'm going to apply laws of logarithms. So I'm going to say, let this function, I'm going to call it m, let m be what? X to the power y to the power z. Okay, then by taking natural log on both sides, ln m is equals to natural log of x to the power y to the power z. And what I'm going to do, I'm going to drop the power. Okay, so it's going to be ln m is going to be y to the power z ln x. Okay, so as you can see, I want to differentiate with respect to y, so x is going to be a constant, but unfortunately m is not a constant, it's now a variable. So if I differentiate both sides with respect to y, okay, so I'm going to say partial y ln m partial y to the power z ln x. Okay, change the marker. Okay, so what I'm going to do here is that if I differentiate ln m with respect to z, it's now implicit differentiation. So it's going to be the derivative of ln m is 1 over m. Okay, but I'm going to multiply by dm dy, since it's now implicit differentiation. And here I'm going to just drop the power, which is z y to the power z. I'm going to subtract 1 from the power, negative 1 ln x. Ln x is a constant here. So what is going to be the final answer? So the final answer, I'm going to get dm dy is going to be m z y to the power z minus 1 ln x. Okay, so that means df partial f partial y is going to be, what is m? M is x to the power y to the power z multiplied by z to the power y z minus 1 ln x. Okay, so on this part, what we're going to do, we're not going to, it's not that hard. What we're going to do is just, we're going to apply laws of logarithms. Okay, so I'm going to say, let m be equal to x to the power y to the power z. Okay, and remember, m is now a variable, it's not a constant. Okay, x and y are constant, but m is no longer a constant, it's now a variable. So if I say natural log of m on both sides, I'm going to say ln x to the power y to the power z. Okay, and by natural logs, we're going to drop the power, so it's going to be ln m is equal to y to the power z ln x. Okay, now you can see that we've tried, but z is still on the power of y. We're going to apply we're going to apply another laws of logarithm. Also, we're going to say I'm going to check natural logs on both sides again. So I'm going to have L, okay, of natural log of m is equal to okay, and what we're going to have here is y to the power z ln x. Okay, should have written this in blue. Okay, so as you can see, we have ln m, it's not ln squared. Okay, so now as you can see, we can apply this is product. So let's say we're given log, so ln a b is same as ln a plus ln b. Okay, so we're going to do the same here. So here we have ln m is equal to ln y to the power z plus ln x. Okay, it's not ln x squared, it's very different. Okay, so I'm going to drop the power here. So I'm going to have ln lm is going to be z ln y plus ln x. Okay, and now, so there's a equal sign here, and now we're good. What we're just going to do, we're going to differentiate with respect to z. So what I'm going to say partial z of ln m. Okay, now I'm going to do the same here. Partial z of z ln y plus ln x. Okay, so here is where you need to be very careful when differentiating this part. Okay, implicit differentiation. Okay, so what we're going to say is we have natural log of ln m. Okay, so what I'm going to do is that if I want to differentiate ln x, is just 1 over x. Okay, the derivative of x over the original function. So what we're going to do here, I'm going to differentiate. In this case, this is x, ln m is x. So what we're going to say is 1 over m, that is the derivative of ln m over ln m. And remember that it's implicit differentiation. So what we're going to say dm dz. Okay, and we're going to say this is equal to, okay, so as you can see, this is x. We don't have z here, so it's constant, but now we have it's z ln y, so same as like saying 2 to z. So we're going to be left with ln y. Okay, and what now, we're going to multiply both sides by ln m. Okay, so I'm going to be left with 1 over m dm dz, and this is equal to ln y times ln m. Okay, then what next? I'm going to multiply both sides by m, and I'm going to be left with dm dz is equal to ln y ln m times m. Okay, and now we're good. We're only just left with substitution. So I'm going to say ln y. What is ln m? It's ln x to the power y to the power z times x to the power y to the power z. Okay, so as you can see, this is the final answer. Okay, then instead of writing x to the power y to the power z, there are many ways, but this doesn't matter because the value of this function will remain the same. But if you want to look like a genius or not, I don't know, but this doesn't matter. Okay, so you can write this in terms of e and ln. So we're just going to use this concept. Say e to the power ln a is equals to a. Okay, was exponential raised to the natural log is equal to 1. So here we can just say this is equal to e. Okay, and we want x, so I'm going to say ln, okay, ln x, okay, y to the power z. Okay, so as you can see, we can just drop the power here, so it's going to be e y to the power z ln x. Okay, it's another way. What is the other way? You can just say we want x to remain on the base. Okay, but here we have z to the power, we have y to the power z, so you can just say e to the power ln y to the power z. So you can see this is equal to 1, so that this is equal to x. We're going to draw the power e z ln y. Okay, it's another form. So this is one way, two way. Okay, then you can just, let's say we can say e to the power x, so we're going to say ln x, so this is equal to 1. Then after that I'm going to substitute this, so it's now going to be e to the power z ln y. So as you can see, it's just the same. Okay, so thanks for watching. Don't forget to subscribe. I hope for your support in forms of comment, sharing, and subscribing.